So I'm here to explain very briefly the communication part for the demo 3D Fab Lab digital twin with 5G slicing and QoS monitoring. So this is a demo in which we have some parts, like the OI box providing the 5G system capable of network slicing. To transmit the 5G network over the air, we are using an NI USRP X410. And then we have connected two user equipments to Quectel boards. These devices are capable of having connectivity to two different slices, connected to host laptops, to which we can then connect the VR classes. The 5G network can be controlled over the OIBox dashboard, in which you can see the network parameters, you can configure slicing and extract some key performance indicators over the 5G network, and the end-to-end quality of service monitoring can be done using the Quasium scope. And for this demo, we are using the 3D engine as an edge node. Starting by the 5G network, we have the core network and the OCU connected to the ODU through a 25 gigabit per second interface, and then to broadcast the network over the air, we have this NI USRP X410, which is now transmitting a fully fledged 5G network, 100 MHz channel bandwidth 2x2 MIMO, connected to these two UEs. So this UE is on the enhanced mobile broadband communication slice, so the base slice, whereas this UE is connected to the ultra-reliable low-latency communication slice. So even if the 5G network is fully crowded and out of resources, this UE will always be able to maintain low latency and some throughput enough to support the demo. The statistics can be shown using our OIBox dashboard, and the quality of service can be monitored using the Quasium scope, where you can see packet loss and delay and jitter.
Part of the use case of 3D digital twin of this demo. So this is a showcasing of Creative Cyber Studio. It is kind of the digital replica of the Fabrication Lab, Fab Lab, in the production line. And then now, thanks to the 5G connectivity, this VR glass is connected to this virtual reality room, and then multiple users, now is currently 2 users connecting under this one single digital room. So people can join online and then discuss the design. This is a Cyber Studio. Discuss the design and then control the real machine of those. So the current limitation of the remote work is how to discuss the 3D design of these physical things, how to discuss with this by the video or voice, only that. But because of this digital twin, 3D digital twin solution, exactly same size, same shape, people can see, also can hold in the virtual reality world. So now I can enter the digital room and then showing what is happening on this. Now I'm in the digital world. Then I'm holding the egg as we want to design. And then we can check the size and the shape in the virtual reality world. And also after the design is okay, so we can control the real 3D printer from this digital world. So now we can see what is the production is happening on the 3D printer. This is the live view of the video. It's showing top view, side view, and I can know what is happening in the production. Then of course this is connecting to the real production of 3D printer. So now the real world is about the thinking. The 3D printer here. Then, now with this 3D printer is running, I can see even the virtual reality world, but of course, in the real world, 3D printer is running. And then, like this view, like in the side view, top view, so it can see what is really happening on the production as a surveillance. So we can see not only the virtual reality, but also reality, real world, we can see both. So this is the power of the connectivity, and then kind of what is the next communication.